So in this lecture, I'm going to give you a slightly more extensive example of using random numbers. And this is basically a program that simulates a game called craps that is played with two dice. The rules of the game are actually quite straightforward. You have two dice. You roll them together, and on the first roll, if you get a 7 or an 11, you win. And that's the end of the game. You win. If, however, the sum of the dots you get is 2, 3, or 12, you lose immediately, and the game is also over. If you get anything else, meaning the sum is 4, 5, 6, 8, 9, or 10, then the game continues. And whatever number you got in that case becomes, we call them, those are your points, your point, okay? What you do now is you keep repeatedly rolling the two dice until one of two things happens. Either you get the same number of points again and you win the game, or you roll a 7 and you lose the game. So win or lose. So obviously we're not that interested in the game itself. What we're interested in is demonstrating some new C syntax, some new features, some new functions in C. So the new things in this one are, well, actually not so new, is first of all, as you can probably, as you figured out, we'll be rolling dice repeatedly, which means it's a good idea to put that into a function. And we're not actually interested in simulating the rolling. What we're really interested in is, if we roll two dice, what is the sum of the numbers we get on each of them. So for that, we will write a function called roll dice. Doesn't need anything as input, which means the argument is void, and it will return an integer between 2 and 12. In addition to that, we'll be using another feature called enumeration. And there's a keyword that we use for that, enum, short for enumeration. And what enum does is it allows you to replace integer numbers with word representation, with symbols. And if you don't specify what each symbol stands for, then what happens by default, the first symbol over here is this word in all capitals, letters, continue. That gets mapped to the number 0. The next one gets mapped to the number 1, and the one after that to the number 2. So they're all going to be positive integers at 0, starting at 0 and then incremented by 1. This happens automatically. You can map these to other numbers. We'll do that a little later on, but for now, this is what you need to understand. We have enumeration status, and we map that to these three labels: continue, won, and lost. And we use these to keep track of the status of the game. We have a main function, of course, and in that main function, the first thing that we do is we set a seed for the randomization function rand. And we already read about that. We already tried it out, actually. We use the srand function for that, and we're going to seed this with the system time. The purpose of doing that is that so that each time we run this program, we get different outcomes. The program runs differently, gives us different results, kind of like what would happen if you roll the dice. Otherwise, this program wouldn't be much fun if every time you run it, you get the same output. Wouldn't be very random. We define an integer, my point, which is the sum of what you get at the roll of a dice, at the roll of the two dice, the very first time. If you immediately win or lose, that's one thing, but if you don't, that is the number of points you have to get again when you keep rolling after that. We have an integer game status, but we're not defining that as an integer, we're defining it as an integer of type status, enumerated status, which we defined up here. So in a sense, status becomes like a new kind of data type. You can think of it like that. It's not exactly what's happening. Game status is, after all, at the back end, still one of these three integers. And that it is only one of these three integers is specified by putting, instead of integer, enumeration status over here in front of it. So game status is an enumeration of type status. Think of it like that. And then we do the first roll of the dice by calling the roll dice function. Now, we haven't looked at the roll dice function yet. We've only seen the prototype up here. We haven't seen the definition of the function. And the return value from the first roll of the dice is stored in sum, another integer. And in the main function then, we check what the value of sum entails using the switch statement. And like I said, the rules of the game are, if on the first roll you get a 7 or an 11, you win the game. So we set game status equal to 1. You can see that using enumeration can make code much more readable. Now, if this would have, game status had been defined as a simple integer, in this line, or in place of this statement, we would have something like this: game status equal to, I think it's 0, right? Now, if you see this line, this statement in place of this line of code, this wouldn't tell you what it means, right? Did we win? Did we lose? What happened? So using enumeration is a great technique to make your code more readable. Doesn't mean you have to use it everywhere, don't overuse it, but in this situation, it works really well. So we set the game status to 1 and we break out of the switch statement. If we get a 2, 3, or 12 on the first roll, that means you have automatically lost the game. So game status is set to lost. And if we get anything else, which is when we hit the default case, we set the game status to continue, meaning we'll keep rolling the dice after this. We set the value of my point equal to the value of sum, and we print out a statement saying point is my point, and we break out of the switch statement. And as long as the status of the game is continue, we want to continue rolling the dice, and that's why this is now followed by a while loop. And in the while loop, we roll the dice, we check what we get, we store that in sum, and we check if sum is equal to the points that we need to see in order to win. If sum is equal to my point, the status of the game changes to 1 and you win the game. Otherwise, if sum turns out to be equal to 7, you lose the game. In either case, the game status changes from continue to either won or lost. Or maybe you don't hit the if statement, maybe you don't hit this if statement, and you come out of this with game status still stuck, set at continue. In that case, you'll keep going through this while loop again and again. But if you hit either of these two if statements, then that will take you out of the while loop because the condition, the while condition, the while condition over here will become false. You come out of it and we print out one last message. If we exit the while loop with game status set equal to 1, we print out player wins. If otherwise, it means you must have lost. That's why you're here. And we print out else, print out the message, player loses. And this over here is the roll dice function, which we still hadn't seen. And if you think about it, once described, once we knew what this function was going to do, we really didn't need to know what happens on the inside, but it's fairly straightforward. Inside, we define an integer die 1 and another integer die 2. Each of them contains a random integer between 1 and 6, and we already know how to generate that. So we use the rand function mod 6, and we need to shift that from the range 0 to 5 to the range 1 to 6, and for that we add 1 to both of them. And we then print out a message, player rolled whatever die 1 was plus whatever die 2 was equal to the sum of the two. And over here for these three placeholders we have die 1 for the first placeholder, die 2 for the second placeholder, and die 1 plus die 2 for the third placeholder. And of course we have to return the sum of die 1 and die 2, so we return die 1 plus die 2. And that's all of it. That's the whole code. If you run this, you'll see output like this. So on the first roll, let's say somebody gets 11. Remember, 7 or 11 will win you the game immediately. So let's say someone gets 5 and a 6. Is 11, you'll see the message printed out, player wins. Done. Somebody rolls on another run of the program. Somebody rolls 4 and 1, which add up to 5, which is neither an immediate win nor an immediate loss. So it just prints out point is 5. So now you have to get these points. You have to keep rolling until either you get a 7 and lose or get 5 and win. So we enter the while loop that we had in the main function, and player rolled 6 plus 2 equal to 8. Okay, nothing. We continue. On the next roll, 2 plus 1, 3. Nothing. We continue. On the next roll, 3 plus 2, 5, which is equal to the point, you win, and we see that statement, player wins. Here's another example where you lose immediately. So let's say on the first roll you get 1 and 1, adding up to 2, player loses immediately, and the game ends. Another time, let's say you get 6 plus 4, which is 10, which means you continue playing. On the next roll, you get 3 and 4, which is 7, which means you lose. So these are all the kind of the 4 possible outcomes you can get. Either you win immediately, or you win later, or you lose immediately, or you lose later. So yeah, this is basically written description that you just of the entire program, which I just explained. So yeah, roll 2 dice. First roll decides whether you win immediately or lose. So that's the rules. So enumeration, we just saw that in action, makes your code more readable. And usually once you have you cannot change, I should say that you cannot change the mapping of integers to labels that you set at the beginning. And like I mentioned, enumeration starts with integer 0 and is automatically, all labels automatically after that receive a value or are mapped to values greater by 1. So in our case, continue had the value 0, 1 had the value 1, and lost had the value 2. Like I said, you can change that, but we'll get to that a little later in chapter 10. If you try to assign a value to an enumeration constant, to one of those labels that we have, to one of those labels that gives you that'll get you a syntax error. So it's recommended, actually not just for enumeration, but actually for all kinds of constants. Usually what we like to do is we assign labels with all uppercase letters to constants because it makes them stand out and allows us to immediately see that we're not dealing with a variable that can change value during the run of the program, but something that will stay constant. And I think should be very clear. So on the first roll, if you get 7 or 11, you win immediately. You get a 2, 3, or I think a 10, you lose immediately, else the game goes on. So the game can either end after the very first roll, or it'll continue in the while loop after that, and where you keep rolling again and again, at least one more time. And as a matter of fact, if the rules of the game on the first slide are not very clear, if you read through the code, that actually clarifies it even better than the description, the text description that we saw. Okay, and I'll show you this code in action in the hands-on section. Other than that, structurally, this program basically contained two functions, main and roll dice. And in main, we had switch statement followed by a while block with nested if-else blocks with an if nested inside the else, followed at the end by another if-else block to determine what message to print out, whether the player has won the game or lost the game.